Today we're going to talk about properties of our exponents. Being able to work with our exponents is going to be critical in your success in algebra and a lot of your math courses going forward. So understanding how they all can go together through our different operations is really important. Today we're going to talk about some of the rules that will help us put together the exponent laws, and we're going to use the kind of meat on the side here, SPAM, to kind of come up with the acronym MAD SPAM, which may be a way to kind of help you remember some of these. So basically the MA is going to be what we help ourselves remember what happens when we multiply powers that have the same base. Now, it's important that we learn this, that the same base has to be there. Okay? But if I am multiplying two powers of the same base, all I have to do is add the exponents, and I keep the base, and then I can just go from there. So I'm going to jump all the way down here into example 1 where you see letter A. So you'll notice that we have base of 3's, which means what I'm going to do is multiply, keep the 3 base, and I'm going to add the exponents. And that's going to give me 3 to the 8th power using MADSPAN. Now you might say, I don't really understand why that works or how I get that. Well, the other thing we can do here is we could have done the following. So 3 squared would be 3 times 3. Then 3 to the 6th power is 3 times 3 times 3 times 3 times 3 times 3. And if I look at all that, there are 1, 2, 3, 4, 5, 6, 7, 8 3's. So I get 3 to the 8th. Now obviously I could expand these out and do this for each one of these. It'd be better if I could just learn my MADSPAN rule. If I see same base, 3's and 3's, I add my exponents and I'm done. So let's move on to the second two. So D and S. So when I divide, again, same base is important. This time, hopefully you will see that S means that we subtract the exponents. Okay, the bases stay the same, we just subtract. So looking at this next one here, we have negative 4 squared divided by negative 4 to the 7th. Well again, basically that is saying negative 4 is my base, and I take the exponents from top to bottom and do 2 minus 7, which is basically going to give me negative 4 to the negative 5th power. Now in the directions it says we would like our answer to be in positive exponents. So let's remember back to the negative exponent. So basically for the negative exponent, what we said was we take the base and we flip it upside down, which would make my base now negative 1/4, and it's now to the positive 5 power. Okay. This one maybe is a little bit harder to kind of understand how this is playing out, and I'm not going to have a lot of room to be able to do this. So I think what I'll do is I will do this one, but up here a little bit. But if I go back to the beginning, if I just expand out my numerator, I have a negative 4 times negative 4. That's what negative 4 squared looks like. In my denominator, we will have 7 of those. Nope, I got 6. So 7. Okay. When we simplify fractions, we look for common factors in both numerator and denominator, and I would notice that I have a negative 4 and a negative 4 that make a 1, a negative 4 and a negative 4 that make a 1, which is basically going to leave me with a 1 in my numerator and 1, 2, 3, 4, 5 negative 4's in the denominator, and again that comes back to showing me how I get negative 1/4 to the 5th power. So on our last one, we now see the PA and the M. So PA and the M. So for the PAM of Mad Spam. This one is called power of a power. This is basically when we have an exponent being raised to another exponent. When this happens, we will only usually see one base, but we see two exponents next to each other, usually one on the outside of parentheses. When this happens, the M means that I multiply my exponent. So looking at C, again we have Z, and we're going to take a 4 and multiply the negative 3 to give me a Z to the negative 12 power. You're just multiplying the exponents. Now again, we wanted to see the negative exponent as a positive exponent. So remember to do that, we flip the base and it becomes 1 over Z now to the positive 12 power. Now I want you to try the next 3. Pause the video, try those 3, and then come back on and I'll show you the solutions. So the first one, you should have gotten 10, which are our base. Add my exponents of 4 plus a negative 6 to get 10 to the negative 2nd power. And then again, we flip our 10 to become 1/10 to the 2nd power. For example, B, remember the 8 only goes to the 5, and the 4 only goes to the 5. So when I kind of write that top one out, the negative 1's just kind of stay out separately. They're not really part of the bases, but negative 1 cancels with negative 1 to become a positive 1. And then I can just focus on my Mad Spam rule. My 5 to the 8th minus 4th is going to give me 5 to the 4th power. And lastly, we have 6 negative 2nd raised to the negative 5th. This is power of a power, which means that I'm going to take the base of a 6, multiply my two exponents, and get 6 to the 10th power. There are two other properties that we're going to use quite a bit. One is called the power of a product. An example of the power of a product might look something like 3 times 2 to the 5th power. Now you might say, well, I would just multiply 3 times 2 and then raise it to the 5th, and that's true, but I think we just want to kind of see how the numbers would work the way they are. When I see this, what I want to make sure that we do is we have to be careful here. That 5th power, the very first thing that 5 hits is that parentheses, which means everything on the inside has to get the power. A lot of times we'll make the mistake here of saying the answer is 3 times 2 to the 5th without the parentheses. We need to make sure that this answer comes out to be 3 to the 5th times 2 to the 5th once they come out of the parentheses. Again, the 5th power with the parentheses being the first thing it hits, the 3 gets the 5 and the 2 gets the 5. So in an example as far as algebra goes, I might have a b to the m power. That has to be a to the m, b to the m. It can't be a, b to the m. The m has to go to both. On the quotient, power of a quotient, it's kind of the same idea. We have 3 over 2 to the 5th power. We have to make sure that both my numerator and my denominator get the 5th. Can't just be the top one only. The parentheses help ensure that both of them get the 5th. It's really like saying 3 halves times 3 halves times 3 halves times 3 halves times 3 halves. And again, as the algebra look, this would be a, b to the m, which would be a to the m, b to the m. And again, just a little bit of a restriction here. B cannot be a 0. Basically because if we had it as a 0, we'd be dividing by 0, which would make our answer undefined. Okay, so we're just going to run through a few examples and then have you try a few. So in this first one, this is a power of a product. We have two different things, negative 1.5 and a y are two different bases. So our negative 1.5 gets the square, and our y gets the square. So we have to remember that both things get the square. On the second example, again, this is the power of a quotient. So we have to remember on this one, a gets the 3, and also negative 10 gets the third. They both have to get the cube or the third power. On the last one, we have the same idea. We actually have a little bit of a mixture of this. We kind of have a power of a product on top of a power of a quotient. So here's what we got to think about on this one. So the first part we're going to look at is we're going to get 2 to the negative fifth, x to the negative fifth. That's my numerator. Then I'm going to, the denominator, get 3 to the negative fifth. Now we need those to be positive exponents. So here's something that we have to kind of be careful on and work through. When I have something like this one where I've made a fraction and I've got all kinds of things happening in this, I don't really want to make my reciprocals in these and try to flip them all over the place. The easiest way to do this is the following. If 2 to the negative fifth is in my numerator, I'm going to flip it down to the denominator, and it becomes 2 to the positive fifth. So now, instead of being in the numerator, it is down in the denominator. Then I'm going to move on to the next number. So x to the negative fifth is in the numerator, so I'm going to drop it into the denominator, and now it becomes a positive. And then lastly, this 3 to the negative 5. Because it is in the denominator, this time it's got to go up to the numerator, and then it becomes a positive 5. So don't make those more difficult than they are. If you have a number to a negative power and it's in the numerator, you can drop it into the denominator to make it positive, and vice versa. Flip a denominator up. So I want you to try the next 3. Pause the video and we'll come back with the answers in a second. So here are your 3 answers. Hopefully you have those correct. We'll just kind of go through these real quickly. The first one again is power of a product, 2 bases, so 10 to the negative third times y to the negative third. Both of those are negative exponents, so they're going to flip into the denominator and become 1 over 10 to the third y to the third. On the second one, we're basically going to be ending up with negative 1 to the fifth, which becomes a negative because it's an odd number of negatives. 4 to the fifth, n to the fifth is the power of a quotient. And on this last one, this is a little bit trickier, but we actually have a couple of things. We have the power of a quotient. So I'm going to do 1 to the fifth, but then I have down here the power of a product and also a power of a power. So there's really 3 things. So down the denominator, I'm going to do 2 to the fifth, from the 2 here to the fifth, and then notice here the k squared to the fifth becomes k to the 10th. I'm multiplying those. 1 to the fifth can just become the 1, and then we get the rest of that. So the last one's a little bit tricky. There's obviously a whole bunch of those kind of mixed in together. So on this next one, we're looking at finding the volume of a cylinder. Volume of a cylinder is pi r squared h. We're looking for some information that we have. Here we have the height of the cylinder. Remember, the height is not the vertical height always, it's the distance between my circled bases. So the height we don't have. The radius we have, but we have it kind of in a weird form. So really what I got to do is plug this in for what I have and not just deal with what we don't have. So h over 2 is my radius times height. So here's where I'm going to use my exponent rules. This is the power of a quotient right here. So that becomes h squared over 4 because it's h squared over 2 squared. We also have pi times h. Now whenever you multiply fractions, I could think of this as h over 1 if I wanted to. It's going to become h squared times another h, which would really be to the first power, even though we only see just regular h. So volume is going to equal pi h cubed, because when I multiply 2 of the same bases, I add the exponents, and it's all over 4. Now if I look through this, the answer is actually sitting right next to us, so we would say there is our answer, but I think this is the part right here that we need to understand and see how this one works. is I want to make sure I see that this h squared times h becomes h to the third, because we add the powers, and then we can finish that one. So here we have one application that we want to kind of work through with our scientific notation. Remember, scientific notation is something where you're going to have a number times 10 to some power. This is where we have numbers, our big numbers with the positive exponent, and our little tiny numbers for our negative exponents. Remember, the number on the front here has to be a number that is less than 10, but 1 or greater. So to be very specific, to being scientific. Well, when I look at this first example, I'm talking about the jellyfish having this much particles of light, or photons, in 6.25 times 10 to the negative fourth seconds. How many photons the jellyfish emit each second? So basically this is kind of looking for a unit rate. We're looking for something for each second. So basically what I want to do is I want to do 1.25 times 10 to the 8th divided by 6.25 times 10 to the negative fourth. It looks really complicated, looks really crazy, but remember, when you multiply and divide our scientific notations, you multiply or divide the like terms. So basically what I'm going to do is I'm going to focus here on this front number. 1.25 divided by 6.25 is 0.2. Then I can focus on the next one here. Bases of tens. Dividing means I'm going to subtract my exponents. So this is going to stay as the base of a 10. 8 minus negative 4 is 10 to the 12th. Well, this is not in scientific notation, so I have to make it turn into scientific notation. So to do that, I'm going to have to move this decimal place over one place. By doing that, I'm going to actually have to adjust my exponent. So instead of being the 12, because I've moved one closer to the end line there, it's now going to be to the 11th. This is now scientific notation. That would be in scientific. So in standard, I'm going to have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. That would be in standard form, which is the normal way we kind of think of how we write our numbers. So standard form versus scientific. The only thing that we probably want to make sure we add here is that we want to maybe add per second.